So previously we talked about heat, and in this video we're going to talk about the other type of energy transfer, which is work. Okay. All right, and so in engineering, whenever we discuss work, just to reiterate, work is just the energy transfer that's not thermally driven. So work is the transfer of energy between a system and its surroundings that is not thermally driven. Okay. All right, and so another way to think about work is that it's synonymous with effort. I.e., it took this much work to do something. It took this much effort in order to accomplish this goal, right? And so the two words are one and the same, right? And so for heat, there's basically, you just had heat. It's a thermally driven sort of energy transfer. But with work, we actually have different types of work that we can consider. Different sorts of sub-classifications of work. Right? And so now I just want to go through some examples of different type of work phenomena that you'll encounter. The first one, and perhaps the most common one that you'll see in this course, is mechanical work. Right? And so mechanical work is any type of work that moves a system boundary. Either expands it or contracts it. So any work that moves a system boundary or causes the system to change sizes. All right? And the most common way we could illustrate the concept of mechanical work is by considering what we call a piston cylinder system. Okay? And so in this piston cylinder system, let's imagine that we have this rectangle represents like a cylinder of some sort. And then there's like a big piston that's inside the cylinder. Okay? So this is a piston. Inside the cylinder and underneath the piston, let's imagine we have some sort of gas. Right? And let's take the gas underneath this piston to be the system. Right? And so initially, let's say the piston is at some height here, and the gas has some sort of volume here. Right? Then let's say, we heat the system, or we do something to the system that causes the gas to expand and push up the piston. Right? And so initially the gas was here, but then at the end the gas is now like this, where it expanded and pushed the piston up. Okay? And so in this case, our system had this size, but after it expanded, it now has this size. The system size has now changed to be bigger. Okay? And so what happened here is mechanical work. The gas was able to expand itself and make its system boundaries bigger. And so what I want you to consider now is, if mechanical work occurred here, is that mechanical work term positive or negative? Pause the video here and think about the sign of the work term. All right, and so in this case, we started with a gas that was this big, and then the gas expanded so that it's bigger. In order for to do that, the gas had to expend energy, right? In order to expand, it had to push this piston upwards, right? In order to push something upwards, basically it was applying a force against the piston so large that it counteracted the mass of the piston down, right? And so basically the gas was working against the piston, or another way to think about it is that energy from the gas went to the surroundings, went to the piston, that allowed it to push the piston up. Okay? And so, in other words, what that means is that our work term here is actually going to be negative, right? Because energy is transferred from the gas to surroundings, right? The gas had to expend effort in order to make itself bigger, right? It took effort for it to expand, right? And so because energy is going from the gas to the surroundings, that means that the work term is negative. Okay? And so qualitatively, we could think about mechanical work in this sort of way, right? To be more quantitative, we could calculate the way that we define mechanical work is that it's going to be equal to the negative of an integral of a force exerted by the system times a displacement x. Okay? And so force exerted by system and this is a displacement. Okay? And the negative here is just to make the signs agree. You know, if the system is expanding, right, your work term would need to be negative. Okay? All right, and so mechanical work is one of the more common types of work that we'll see in this course. But there are others as well. Okay? For instance, shaft work is another common type of work that you see in chemical processes. Okay? And so shaft work is due to forces acting on a shaft in order to turn it against some sort of mechanical resistance. Okay? So work due to a force acting on a shaft to turn it against a mechanical resistance. Okay? And a more kind of layman's term way of describing this is you could think of it as just mixing. So anytime you're mixing something, there's shaft work going on. Okay? To illustrate this, let's consider a system where we have a liquid and then there's like an impeller here. Okay? So we have a liquid. The liquid is being mixed. Okay? All right, and so some sort of electrical energy is being applied to this impeller in order to mix the liquid. And so in that case, we have a work term. Well, what's the sign of the work term? Okay, pause the video here and think about what that sign is. So energy, if we take the liquid to be our system, and energy from the impeller is being transferred to the liquid, that means that our work term here has to be positive. Okay, so work is positive because energy is transferred from impeller to liquid. Alright, the next type of work I'll discuss is flow work. And this is work that's due to a fluid being pushed into the system by the surroundings. And so flow work typically is more often encountered when you're dealing with open systems. All right? And it just has to do with the fact if you're pushing a fluid through your system from the surroundings. Right? And the work that's required in order for that system to push the fluid from the input to the output. All right? And so flow work is work performed when a fluid is pushed into the system by the surroundings and the work a system does to push the fluid to the exit. Okay? Alright, and so the key here is when you think of flow work, you need to think of pressure gradients and friction. Okay? And the most common way to illustrate this that you'll see not only here, but even in your transport phenomena courses and the rest of your undergraduate classes, is just think of a pipe, right? Where in this pipe you have a fluid flowing in, and the left side is at pressure 1, and then on the right side of the pipe the pressure is at pressure 2. And pressure 1 is greater than pressure 2. Okay? And if we take the pipe to be our system, we see that if the pressure is higher on the left side than the right side, that's going to push the fluid through. All right. We'll talk more about flow work when we start dealing with energy balances for open systems. The last type of work I'll discuss here is electrical work. And it's work that occurs due to an electrical current passing through a resistance in the system. Work that occurs when an electrical current passes through a resistance in the system. Okay? All right, and so for work, these are the 4 that we'll typically encounter in this course. Although they aren't the only ones that we'll encounter.